Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello students, today we will discuss about formation of longitudinal wave. Let us see how longitudinal wave is formed. So let us begin with longitudinal wave formation. Students, let us start with the formation of longitudinal wave. Longitudinal wave is like sound wave, where if a wave travels in this direction, then the particles of the medium vibrate along the propagation of wave, along the direction of propagation of the wave. That means it vibrates to and fro along the direction of propagation of the wave. This is longitudinal wave. So the particle vibrates in a direction parallel to the direction of propagation of the wave. Then let us construct the wave profile of or waveform of this longitudinal wave. I will consider, we know that when a particle vibrates to and fro, it goes towards extreme right from mean position, comes back to the mean position, goes to the extreme left and comes back to the mean position. So this completes one oscillation. So when the particle which receives the wave or distance first, when it completes one oscillation, what about the particle which is at a certain distance, say lambda wavelength upon 8 apart, what will happen to that particle? Or we can say that when this particle completes one oscillation, the particle which is at a distance of one wavelength will start its disturbance, will receive the disturbance, and in between those particles which are present, they might be in some different positions away from their main positions, because they must have received the disturbance earlier to the particle which is exactly at a distance of one wavelength apart. So if I divide this wavelength distance into few equal parts, 8 equal parts, and see all those particles present, how they behave when the disturbance starts from this first particle, and in steps we will not consider the disturbance as one complete oscillations in one shot. We'll only consider when the disturbance is t by, if the total time takes is capital T, time period of oscillation, I will take t upon 8. I will divide the time into 8 equal parts. So in t upon 8, how far it goes? Obviously it goes to the amplitude position, extreme right position in time t by 4. So we'll divide the time into t by 8, t by 4, then 3t by 8, then 4t by 8, and so on, and we'll reach at 8t by 8. So during those times we'll see how, as the particle gradually moves from one time t by 8 to another time t by 8, in each steps what will happen to the other particle nearby. So I'll consider the diagram like this: 1, 2, I have considered 9 particles. This is the first particle which receives the longitudinal wave. At t equals to 0, when this particle is just about to receive the longitudinal wave, at time t equals to 0, it receives the longitudinal wave. Then what will happen in the consequent time interval of t by 8, where t is the time period of oscillation of each particle. So I will first draw the this is t by these dots are, I'm not making it very large because I have to shift these particles. So just a previous assumptions that the particle was here, I'm just giving a dot, but this will change to its new position. So therefore just faintly given. So this is how it completes the total time of oscillation 80 by t. So this is the time of one oscillation. During one oscillation of this particle, how the particle which is at a distance of one wavelength apart, how that is divided, how this particle will behave. So now this is the line. I'll just draw it first. 1, 2. This is the initial position of the particles. Just as a reference line, you will draw this. And this is the last one. So what I have to say is that these are the particles of the medium. I consider this line where 1, 2, 3, 4, 9 particles are lying in a line. When this particle will receive the oscillation, then it is here obviously, and it will not shift to any position because it is about to start its oscillation. So after time t by 8, means if I divide the time of oscillation into 8 equal parts, then t by 8 times, in t by 8 time, it will move towards right, suppose, in the forward direction, because it has to move in this way, to and fro. So this has to move, but how far it will go? Because we know that to reach the maximum, to reach the amplitude position, it will take time t by 4. So in t by 8, it will reach half the amplitude. Obviously, exactly is not half the amplitude because oscillation time is not equally divided. But still, we will say that it reaches half or nearly half the amplitude. It is more than half the amplitude, but we will say that it is half the amplitude. So, if this, it will then move to some position. Suppose this is the amplitude position. This distance is suppose amplitude position. Then it will be reaching somewhere here. So this will move up, but I will not draw here, I will draw somewhere here. So this is the position of this particle. This particle will move forward here, I will draw here. This is the position of the particle. Now we can join those particles. This is particles, these are the particles which are never going to vibrate. These are the particles which are never going to vibrate, and their positions, initial positions was here. Normally, in time t equals to 0, no part is vibrating, and now at time t by 8, this will come to half of this amplitude. I consider this as the amplitude, so it will come midway between this, but come to this position. Okay, so it will come to this position. So this particle will move to this position. So this is the case. Okay, and this particle is about to receive the oscillation, and the remaining particle will be as usual. As usual, it will remain straight. Now, if I give one more t by 8, this will come to the extreme position, that means amplitude position this here. So it will come to this position, this position. This particle will come to half the amplitude, it will come to this position. Okay, now this particle is about to receive the oscillation, and the remaining will be as usual undisturbed. Now another t by 8 time, this will move forward, it will come to its extreme position. Its extreme position is here, so it will come to in this line somewhere here. This particle will move to half the amplitude, so its half amplitude is somewhere here. I will use another mark for the movement of the particle. So this is the blue one, this will move to this position, this will also move to this position, new position. So this will move to this position, and this particle will about to receive the oscillation, and this will remain as it is. So this particle will move to, second particle will move to extreme position. This particle which was at extreme will come down to the midpoint of this line. It will come to somewhere here. Okay, and this particle has moved to the midpoint. This is about to receive the oscillation. Now in next t by 8 time, this particle will go to its extreme, and its extreme is here, so somewhere here. So this will move to the extreme. I will use another color so that you can distinguish. This will move to its extreme, and this particle will now be half the amplitude, so it will somewhere here. This will be somewhere here, and this particle is about to receive the oscillation, and the remaining particle will be as usual undisturbed. What will happen to all those particles? You can see here that this will also move, every particle will move by t by time. This moves to here, this moves to here, and this is the extreme, so it will come to its mid means this line and this point, because this is the midpoint, so this will come to here. This is at its midpoint, and it's come to mean position. Mean position is this line, so it will come to this position along this line, so it will come to this position. Okay, and now this is about to receive the oscillation. When this reaches here, it receives the oscillation. So in next t by 8 time, this will move to now it is at midpoint, so it will go to extreme. So its extreme is this 5th position, so it is somewhere here. So this particle will come to somewhere here. That means this one will move to its extreme somewhere here, and this particle will move to half of its amplitude, so it will come to somewhere here, half the amplitude, half the amplitude. This is about to receive the oscillation, and this will remain as it is. By that time, we will draw the profile for other particles. This particle which is at the extreme now come to mid position, so it will come to this one, this line, this one, and this is at the extreme, this is at the mid, so it will come to mean position. So this is the mean position line, so somewhere here it will come to somewhere here. This is the mean position line, this is the extreme position line. Okay, now this is what mean position, it will go to the other side, so other sides and mid position, so it will come to somewhere here, mid position, so it will be like that, so like this, so all these particles will show in one line. Okay, so by that part, by the time when this fifth particle goes to half the amplitude, this fourth particle is at the extreme, the third particle is at the midpoint on the right side, and the second particle it has completed a half oscillation, and this particle has completed more than half oscillation and goes to half of the amplitude in the other side of the oscillation, mean position. Next, I give one more t by a time. This will go to its amplitude position. So this amplitude is here, so it will come to amplitude position. So this particle will now move to here. That means it is oscillating, will be showing like that here, and this particle will come to half the amplitude, so it will come to somewhere here, half the amplitude. And this one is at the this one is at the extreme, so it will come to mean position, so it will come to somewhere here. Similarly, every particle will move by that stepwise. This will come to its mean position somewhere here, because this is a line of mean position and that is the position of this particle. This is at the mean position, it will go to the midpoint of that, so midpoint on this line is here, so it is like that. This particle is at the midpoint, it goes to the extreme point, so this will go to the extreme point. Suppose this is the extreme point, so it goes like that to the extreme point, so they are now like that, and this is about to receive the oscillation. When this particle goes to in another t by time, this will go to its maximum position somewhere here. Okay, so this will come to the maximum position somewhere here. This will go to the mid position somewhere here. Okay, somewhere here. This will be at the maximum, it will come to mid position somewhere here. This is at the midpoint, it will come to mid position in this line somewhere here. This is at the mean position, go to the other side, and mean position, midpoint of that other side, so it is somewhere here. This is at the midpoint, so it will go to the maximum on this side, so it will come to somewhere here. This point is at the maximum position on the other side, so it will come to midway, half of that somewhere here. So this will be like this, and when this particle reaches here, half of that, so this is about to receive the oscillation, because by each time this completes half a t by 8 time when it spins, this particle spins t by 8 times, the second particle, nearby particle, also receives the disturbance, so this is about to receive the disturbance. By the time when this moves forward by an amount, that is t by time, it will come to its mean position somewhere here. Then this goes to the midpoint, and this is at the extreme, come to the midpoint. This is at the midpoint, comes to the mean position. So this is the mean position line, so it comes to the mean position. This particle, fourth particle, is at the mean position, it goes to the other side and half of that, so it will come to somewhere here. This particle, which is at the midpoint, go to the extreme, so it will come to somewhere here. This particle, which is at the extreme, will come to midpoint somewhere here. This particle, which is at the midpoint, will come to mean position, that means somewhere here. So this is how this completes one oscillation. You can see that the first one completes one oscillation, and the wave profile is like that. Now this confirms that when one particle, we are talking about, I have considered 9 particles. So 9 particles, actually I have divided the total time into 8 parts. So by each t by 8 time, the nearest particle is going to be disturbed. So the first time when time t equals to 0, it receives the disturbance. This starts oscillation, it moves through half the amplitude. This is about to receive oscillation. When it moves to the extreme by another t by 8 time, this is moving to half the amplitude. This is about to receive the oscillation. And when this moves by half the amplitude from the extreme, this goes to the extreme, this goes to half the amplitude, and similarly, and this is about to receive the oscillation. So this way you go step by step, and you will see that when this first particle completes one oscillation, this is a complete wave profile, and at that time the last particle is hit this one, because when this completes one time, well, t by 8, so 1 2 3 4 5 6 7 and 8, by the time it completes one oscillation, this particle is about to receive the oscillation. That means in a wave motion we know that when this particle completes one oscillation, then this particle is about to receive the oscillation. When the number of oscillation completed here is 1, the number of oscillation is here is 0. When it completes 2 oscillation, this is about to complete 1 oscillation. So when this particle completes 1 oscillation, this has not started its oscillation. This distance 1 to 9 is exactly equal to 1 wavelength. So this is how the wave profile is found. Here you can see that this is the region of compression when the particles are closer, and here you can see the particles are farther apart. You can see here this is a region of rarefaction, and longitudinal wave travel in the forms of compression and rarefaction. Here the atoms or molecules, they come closer, it's making compression, and here it is rarefaction. This concave part is for compression, and this convex part stands for the rarefaction. Okay, this is how you form the longitudinal wave. Thank you.